Hello everyone. So what are we gonna be doing today actually is that we will be doing OSPF. Okay. So here we go. So we're gonna be building a basic OSPF topology. We'll be subnetting. We're gonna configure saving configuration, and we're gonna be doing some show commands to see what our configurations are doing. And we're all going to be doing this in packet tracer. I know I have GNS3, but not everyone has GNS3, so it's best to do packet tracer because it's free. So here we go. I'm learning, you're learning, and if I mess up, then feel free to let me know. Okay, so first we're gonna build the basic OSPF topology. First things we're gonna do is that we're going to grab routers. Okay, you can use the 1941 routers. Okay, we'll have a PC like this. Okay, so what we're gonna do is that we're gonna label them. It's always good to label these routers actually. And then we're gonna call this the ISP. So this is where the traffic's all gonna go to in the end. And then we'll just call this a server. We'll call this a server. Remember, when you're learning CCNA, a client, I believe a client can be a server, and a server can be a client. Anything can be a server actually. Including PCs. We also have server right here, but I believe you cannot really ping. Maybe you can. I guess you can ping. But I think it's just best to use PCs because that's most likely what you would be seeing in a lab actually. Okay, and then the next thing we're going to do is actually get more PCs and put them on the outskirts of each router. So if you guys are using an in-lab thing, right, this is what I did for in-lab. We had a group of 4 people. One's going to be the ISP. One's going to be configuring the ISP through command line, or through the command, right? Console ports to each router, and then they will configure each of their own. But we're going to be doing it through packet tracer. Okay, so the first thing that you would want to do is that you would want to connect these first. Actually, we need to label these first. Almost skip that actually. We'll just have these with their own respective ones. So let's go to PC1. Oops. Okay, PC2. Okay, wow, this is a lot. Okay, PC2, PC3, and then now we can rename this to PC1. Okay, the first thing that we're going to be doing is actually, while building the topology, let's go and hook it up. G00, F01, G00, F01, G00, F01, and G01, FG00, and then for this one G01, F00. So here we go. Now look, we got a nice little connection. But how are we gonna connect all these if everything is if everything's all taken? You see, can't really do these, right? So it's just one connection here, one connection here, one connection here. We can't do that. There's no more extra ports. So what you're gonna usually do is that you're gonna go to the physical, and you're gonna turn off the router, okay, and then plug in a serial cable, serial ports, which is what we do in lab actually, in real life labs. You can use the serial port. The serial port turns off, and it needs both serial port ends to activate. So let's go and get a serial DTE, and we'll go and configure this. So here we go. We got serial 010, and then we'll connect it to serial 011. We'll just make this look really uniform, serial 10 and then 11. It's like a little step. All right, great. believe this looks good. We can also turn off with our preferences with always show port labels. We can turn that off actually. Yeah, that looks nice. Looks nicer. So we can subnet this. So yeah, basically it will just look like a little Dorito in the middle with a connection outside. That's basically what we're going to be doing. I believe we can highlight this. We can highlight it. Okay. All right. Okay, there you go. This is good. The show port labels when mouse is over logical workspace. That means we will be able to see it. There you go. Great. So the first thing we're going to do is now the next step that we're going to be doing. Actually, move this over here. Is that we're going to be subnetting. Okay. Let's just say that we would want let's just say that we would want 62 hosts, right? We want 62 hosts for each subnet. Okay. Let's just say we want 62 hosts. Here we go. 62 and host. Great. Oops. There you go. Alright, so let's just say we want 62 hosts per subnet, and then we would want only 2 hosts within each link so we can maximize our IP addresses. So now that we got this out of the way, right? Now that we got this out of the way, right? I don't know what to do for a check mark. We'll just do this. So now we're going to be doing some subnetting. Okay. So this is going to be in the 192.168.1.0/24 subnet. That means that this right here is going to be our network, right? Network, and then this is going to be our hosts. Okay. And I'll write this down to make it nicer, but we're gonna add these bits. So 128, 64, 32, 16, 8, 4, 2, 1. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, great. So since we got 8, 16, and 24, the ones that we're gonna be configuring here is the last 8 bits, the last octet. 5, 6, 7, 8. Actually, let's go and move this down. So it looks, because we're gonna be raising it up a bit. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so what do we need? The formula now, right? The formula of how many hosts, right, we want, right? Because the host that we want is 62, right? And so we're gonna need to figure out how many host bits we need to have in order to make 62. The formula for this is 2 to the n minus 2. Okay? N meaning host bits that we're going to be taking. So let's go and count, right? Let's just count how many host bits we want. Let's see, let's say 4, right? Let's get our calculator. No one's a genius, even me, and we'll do 4. Okay, it looks like we can only fit 16, right? 16 minus 2. We can only fit 14 hosts in here. Let's raise it up. What about 6? 64 minus 2 is 62 hosts. Does that fit everything? Yes, it does. That's actually perfect. Wow. Okay, so we're going to be doing 2 to the 6. So we're going to count 6 of our host bits from right to the left, and we'll slash it off. So 1, 2, 3, 4, 5, 6. Slash. Okay? Just gonna make it look nicer. Slash. So now we have 6 host bits, and we're left with the 2 network bits to play with, thus making this a /26 network, because we got 8, 16, 24 plus the 2 /26. And before we do all that, our /26 subnet mask is going to be all ones in the network bits. So we got 255, 255, 255, 255, and then the network bits, which is 128 and 64. 128 plus 64 will equal us 192. There you go. This is the subnet mask that we're going to be going with. Great. So now that we know that we're in the /26 subnet, and that will give us enough addresses, what are we going to do? We're going to be doing subnetting now. So we will start off with the network of, right? Let's go write this down. 192.168.1.0/24. Now we're going to be subnetting it now, right? We're going to start off with the 192.168.0.1, and we're going to put it as the /26 network. This is going to be our first network address. So it's going to be .0, right? 192.168.1.0 to 192.168.1.64. Okay, so we'll do a 0 and 1. This is equal to 64. Okay, or 63 actually, because you always have to have this is the broadcast, it's the ending broadcast. Actually, we'll do it 62 because, yeah, actually 63, because next one. So here we go. 192.168.1 dot what, right? So the next one is going to be .64 to 192.168.1 dot. Let's go and cancel this out, right? We already used this. So 10. Here we go. This is the 128 now. So 128 minus 1 is 127. 192.168.1.128. Okay, and then slash, and then what is going to be the next network is 192. So 192.168.1.191, and then 192.168.1.192. So now that we have all of our bits taken up, that means we can't really configure the /26, but in actuality it actually provided us with all the addresses that we need for the network. So this is going to be a /26, a /26, and a /26. Okay, great. So these are going to be for each of the PCs, 1, 2, and 3. And we have 1, 2, and 3 networks. Now, we're on the 192 network now, correct? We need how many IP addresses for each of these links? Well, we only need 2, right? For one on R1's interface, one on R2's, one on R2's here to R3. So we only need 2 host addresses. What can give us 2 host addresses? Well, let's go back here again to the calculator. 2 to the what equals 2. Let's try 2 to the second. 2 to the second minus 2 equals 2 addresses. That's a perfect fit. So we're going to be taking 2 host bits. 1, 2, slash. Alright, now let's go see how much, what is the slash of this one. Here we go. So 8, 16, 24, 25, 26, 27, 28, 29, 30. This is a /30 network. And it's going to be equaling to 255, 255, 255 dot, how much is this? Well, let's go and add it up in our calculator. 128 plus 64, see, plus 30, 128 plus 64 plus 32 plus 16 plus 8 plus 4, 252. Okay, so now, okay, this looks pretty ugly. So now our subnet mask for the /30 subnet is going to be 255.252. Great. And now we have all these bits to deal with, you know, we have all these bits to play with. Okay. So what is going to be our next subnet? Right? So of course let's just start off with 1 bit right here. 1 bit. So 0, 0, 0, 1. We already used up these two. So 192 plus, what is this? 1, 2, 4. 192 plus 4. 196, right? So 196, 195 /30. 192.168.1.196. Get it that I'm deleting 1 because this is a network. We want it to be this to the broadcast. So in between is going to be the 192 to 193 and 194. So in between is 193 and 194, which we're going to be using. Okay, so now we're at 196. Let's go and take this out. What's going to be the next one? 0010. Because we're just filling in the second list. That's going to be 192 plus 8. What is 192 plus 8? 192 plus 8. 200. So 192.168.1.199/30. 192.168.1.200. You probably get what's going on here. Our next address is going to be 0011. What is this? So what is 192 plus 8 plus 4? 204. 192.168.1.203/30. 192.168.1.1.204. As you can see, we have 3/30 networks, but I think we need 5. So we got 1, 2, 3, 4, and 5. 5 of these. Great. So here we go. What's the next one? Let's cancel this out. We're going to be using 0100. Believe so. So we are going to be borrowing from the 16 now. So let's go and add 16. So let's go and add 16. Yes. 192 plus 16. 208. So 192.168.1.207/30. 192.168.1.208 network. And I think we just need one more. So the next one would be 0101. So here we go. Let's do this again. 192 plus 16 plus 4. 212. So 192.168.1.211/30. And the next one would be 192.168.212 to so on, right? So here's our subnet. We got it. We got everything we needed. So we got everything we needed. We got 1, 2, 3, 4, 5, and we got our 3 hosts, 5 of our connections, and we'll start it off. Here we go. So we did subnetting. Now we're gonna configure. We'll have this as our thing going on here, and how about we just drag our packet tracer to desktop 1. How about we drag that to desktop 1? Which is nice. Nice to have this. That's good. So let's label it. Let's go and label it. Here we go. We'll start off with we'll just give each default gateway for each PC. We'll do it like this, okay? How about we do the default gateway as .1, and we'll have the host, the PC1, PC2, and PC3, the second host address of the network, just to make it just to make it nice. Actually, let's make it the last one, right? We're gonna use the first usable address as the default gateway, and we'll use the last usable address as the PC1, PC2, and PC3 of each network, its address. So let's go and do .1 for each of these, actually. .1 and .1. And then we'll name it the address. It is 192.168.1.0, 192.168.1.64, 192.168.1.128. We'll also give these while we're at it too. 192.168.1.192, 192.168.1.196, oops, 196, 192.168.1.200, and then we'll have this one into 168.1.204, and the last one 192.168.1.208. See, this is a lot. This is a lot, actually. Lots to do when you're doing these things. Hopefully you're grabbing along, right? Actually, we should label each one as their subnet as well. We'll do this as /26. Each one of these will get a /26 in the end to make it to clarify. It's always good to document your work. Oops, 196, I believe, 192, and we'll do it /30, /30, /30, and /30s. These will have it as well. Alright, so each one of these will have their own addresses now. So each of the default gateways of the router interfaces will be .1. And the last usable address of each one. So let's go see 192.168.0's network. What is the last address? What is the last usable address? .63? No, that's not the answer. Actually, .63 is going to be the broadcast address. The real answer is .62. There's a reason why we do 2 to the n minus 2, because you're taking away the network address which can be used and the broadcast address that cannot be used. The network, broadcast. So anything in between is a usable address. Here we go. Actually, let's move it over here. Looks nicer. Okay, here we go. I know it takes a while to label this. So here we go. This is the .64 now. What is the last usable address? .126. And then let's go to this one right here. The 128 address. This is going to be .190. Great. .1.190. Let's put this leave it, let's put it inwards a little bit, just because. There you go. That doesn't look too pretty. Maybe we'll just do it like that. There you go. Looks nice. It's always good to have everything symmetrical. Now that we addressed our PCs, we'll just address the rest of these subnets as well. So .192, right? Let's hover over these. See what we're going to be dealing with. Okay, so it looks like we started the loop like this. So we'll start off with this right here. Actually, we'll start off with this. Oops. Okay, this is gonna get .193, and this one's gonna get .194. And then this, from the .196 network, this is going to be .197 and .198. This one's going to be, this is going to be .201. This one's going to be .202. This one over here is going to be .205. This one .206. Oops. And the last one over here is going to be .209. Oh. 206. Yes. Okay, that's correct. I thought I was wrong for a second. Okay, .209. And the last one's going to be .210. Great. Now let's go and neatly do this. So we want to have a neat network. That's definitely what you would always want to have. There we go. This looks nice. Everything is all separated. All the networks are nicely put in. Yeah. Okay. Now that we have subnetting in, we did the subnetting part. We put it into the topology, and now we're just gonna configure. Okay. Here we go. Let's start off with this right here. So we'll start off with .62. So we'll statically add it. 192.168.1.62. Oops, not 63. It's .62. 255.255.255. And what is the subnet mask of a /26 network again? 192. Oops. He didn't like that. So .62. .192. Okay, and our default gateway is going to be .1.1, like we did. Okay, great. Our next address is going to be Here we go. Whoops, what's going on here? 64.126. Whoops, this is the wrong one. This is going to be .65. Okay, .65, the address over here, and then this is correct, .126. So the address of this one is going to be 192.168.1.126. Subnet mask .192 for our /26 network, and 192.168.1.65. Great. Let's go back to desktop, IP configuration for this one. Let's move it this way this time so we can see what we're doing. Oh, man, I'm making mistakes today. Okay. Let's go and configure this. This is going to be in the 128. So this should be 129 as the first usable address. Okay, so 192.168.1.190, 255.192, and 192.168.1.129 for our default gateway. Great. Now we configured all the PCs. Now we're gonna get into the fun stuff, which is the routers. We'll just be configuring the routers real quick, and I might as well add an extra one. We configure, the first step we're gonna do is configure interfaces, and we're gonna add in a routing protocol of OSPF. There are different types of routing protocols, like static, right? You're gonna have to add static to go around, but that's not really what we want to do. We want it to dynamically learn and adjust while we're at it, so it's easier. Also, OSPF is widely used because it's not proprietary like the Cisco EIGRP, I believe so, but you know, it's cool to have a Cisco. Okay, here we go. So let's start off with R1. We'll head into the CLI. We'll give it a no, and we're just gonna do some basic stuff. Well, for now, we'll just teach you how to do this. Let's do a hostname R1. We'll do a linecon 0, and we're going to give it a password of password, and we're going to do login. Okay, and then what we're going to do next is that we're going to exit to go to config mode. We'll give it a service password encryption, and we're going to do a enable secret password. Okay, and then if we exit everything, we should have a password of password, and when we enable it, we just enter password, and we're good. There we go. So now we have basic basic password and encryption. And you know what, let's also add a banner of the day. So we do banner MOTD, and then in between we also put these, so you might as well add like 2 of these. This one actually starts the string, and this one is just to make it look fancy. Warning, authorized access only. Wow. And we'll do this. Boom. Right, let's go exit. Right, exit both. Oops, exit both. Oh, password. Oops, I'm really bad at spelling. Alright, it didn't really show there, but it'll show when we turn it off and turn it back on. But yeah, that's how you do it. If anything you want to do is do show run, or a show run to see. See, look, we named the host name R1. We did enable secret. It's encapsulated with the MD5. The secret basically gives it a better encryption. Service password encryption gives it a 7, which is Cisco's encryption thing. But you can always just plug it in online through a decryption generator, and it'll do it. That's why we put in the enable secret command. But there's nothing wrong with having service password encryption. I just do it for practice. Okay, let's see if we got more. We didn't configure any of these things yet, and I feel like we also there you go. Here's our password, the linecon 0. Notice how our linecon 0 only has this password. You see, only a password of 7. That means, see, this is easy to crack up. And then for the banner MOTD, it looks like we didn't really do it well. Maybe we can do another banner MOTD. Banner MOTD, authorize, warning, authorize, access only. This is gonna be a long video, so just hang in tight there. Because there you go. Now we got the warning. See, warning, authorized access only. Great. It's always good to have a banner MOTD because for legal purposes, according to my teacher, you know, if it says if the banner MOTD says, hey man, only at authorized access only, and someone tries to go in there, here's your documentation. The router says, hey, it's only at authorized access only. Why are you there? So yeah. Oh man, we wasted a bunch of time, but you know, it's good to know these things. All right, so let's go configure the interfaces. Okay, here we go. Let's just show R1 right here. And let's go to interface, right? Or actually, before we do that, let's do a do show IP interface brief. And this is the interfaces that we have. We have G00, G01. So let's go and do these. Okay, so it looks like S011 is on this left side. So let's go back in here. So let's go to interface S00/1/1. Okay, great. We'll give it an IP address of 192.168.1.193. And the subnet mask of, from what we wrote down, 252 dot 252, and we'll give it a no shut. Notice how it's only change state to down. You need both sides to make both of them change to up. So let's go to the other interface. So let's go do an interface S01/0. You could always just do this, change interfaces while you're in another interface. It's possible. So let's do 192, IP address 192.168.1.202. It's always good to label because it makes it way faster. See, state to down. Let's go to interface G00. And we'll give it the IP address of 192.168.1.1 255.255.255.192. Almost caught me there. And we'll give it a no shut. Notice how it goes up, because on regular Ethernet interfaces, especially one that goes to the PC, the interface is always up. The NIC card is always up. So that means that this should be up. Now let's go to the .1 interface, right? This time we'll use the longer thing. And we'll go to G000/1. So we do a G tab, right? Or GI interface. Actually, here, let me show you how to do it. So you do IN and then tab, and then you put a G, it'll fix it, and then 0/1 for the other interface, and now we're in here. See, that's the full length. No one really wants to do that, right? And then here's the full one for this one. IP add, it goes address. So let's go 192.168. 1 dot, oh yeah, dot 1 dot 205. 255.255.252. There you go, no shut. And the interface has been set to up. Okay, now let's go and let's go to our show commands. So let's go do a show IP interface, right? Int brief. This will show us everything that we've configured so far. Looks like we've configured everything so far, and if actually we can check in the command prompt of our PC that we can ping, we can ping our default gateway. Great, see? You ping our default gateway. That's good. So R1 is ready to go. R1 is ready to go after having to do the router OSPF stuff. We're going to be doing that later on. We're just configuring the interfaces for now. And for to speed up the process, we'll just be doing only naming the routers for these ones. Okay? Because I just wanted to show you how to do the, what's that called? Just to do the security purposes for router 1. Everything else, you know, everything else you don't have to, like, you know, like, I mean you have to, but just to speed up the video. So let's go to let's do a do show IP interface brief. There we go. Let's go and okay, let's go and drag this over here so we can see what we're doing here. So let's go to interface G00, which should be this one. Yep. Okay, so let's go to interface G00 and we'll go and configure this right now real quick. Let's go do an IP add of 192.168.1.65, I guess so. 255.255.255.192. No shut. Now this one should be up. Let's go and test it out while we're at it to not waste time. 65. Alright, now we're able to ping it. Now let's just configure the rest of the serial ports. So let's go see. Let's do S011 first. So let's go to interface S01/1. Let's go give it an IP address of 192.168.1.197. 197, the subnet mask will be the /30 network 252, and we'll do a no shut. Great. Now, if we go to S01/0 and we'll give it an IP address of 192.168.1.194, okay, 255.252. If we do a no shut, these two should turn green because both have no shut on their interfaces. Now watch this. Boom! Now they're both green. And notice how this one, notice how R1's S011 interface turned up as well. There you go. That's networking, baby. That's it, bro. Alright, now let's go and let's do a do show IP int brief. Looks like we have done everything. This is supposed to be unassigned and administratively down. Oh my goodness, that's a tongue twister. Because we don't have any other interfaces. So let's go do R3 now. Great. So let's go and pull up R3. Okay. Let's pull up R3, go to the CLI. Let's extend it to make it look nice and do no. So let's go and do an enable, right? Okay, let's just do this for now. You can also do enable, but you know, EN for short. Then this is the full command, right? Configure your terminal. Oops. Oh yeah. Okay, configure terminal, and then now let's just continue. So let's go to interface, right? Actually, let's do a do show IP int brief. We only do this because we want to see what we're actually, you know, we want to see the interfaces on this. You know, usually you're not going to have the topology. Usually you're just going to open up Microsoft Excel or something and have all this documented like this. You're not going to see the topology like look like this. Maybe you want to draw it out, which is great. but I don't think you're gonna really be having like a topology looking like this. Maybe you will, but I think like the XL is definitely what you're gonna be seeing most likely. So let's go to interface G00. It's good to have it's good to have being uniformed with the G00 as the first one. And let's go and IP add 192.168.1.129. 255, 255, 255, and .192. And let's do a no shut. Alright, everything's up. Let's go ping it just to test it out. That we have connectivity. .1.129, and we're able to ping our default gateway. Great. Okay. Now let's go to do this one, S011 interface S01/1, and let's go and do this. IP add 192.168.1.201 255 255 255.252. Whoopsies. Oh, look at that. Notice how we have an input valid error and it shows where we have it. So it looks like I did something wrong there. What you would want to do is that you would want to change it. There you go. And we'll do a no shut. Oh, look, see, it even went up. That's great. And we'll also do a interface G0 0/1/0, and we'll give it an IP address of 192.168.1.198 255 255 255 252, and we'll do a no shut as well. Great. So you notice how we have R1, R2, and I believe R3. We all had everything that went up. See, everything went up on these routers. That's great. And then now let's just go and configure the ISP real quick. The ISP, you know, it's important, but you know, it's just to help us figure out, and you know, the ISP here is actually to check if we have our default originate, and I'll show you guys that later on. And let's do a host ISP. Right, I don't know if I did this on, oh, silly me, did this wrong. We're supposed to be also doing host on R3 as well, just to make it all uniformed and everything. Okay, so let's go and configure this. Let's do an int G00. I believe G0 is this one. G00. Okay, great. Oops. Oopsies. There you go. Almost screwed that up. Okay, let's go do an IP address of 192.168.1.206. Notice how we haven't had any problems with the subnetting. If you subnet it right once, you're good to go. Okay? That's all you need to know. And then let's go and configure this PC, because it looks like we have not yet. So let's give it dot 1.210 dot 190 252. Remember, almost screwed me up there. And its default gateway is going to be 192.168.1.209. Yep, seems about right to me. And let's go back here, and we'll go to interface G01, IP address of 192.168.1.209 255 252, and give it a no shut. Great. And let's see if we're able to ping our thing here. So ping 192.168.1.209. There you go. Great. Okay, great. Here we go. So we have it looks like everything is all green. Do you think we're able to ping to the server now? Let's try to ping it. Right, ping 192.168.1.210. And it looks like destination host is unreachable. Guess what we need? We need routing protocols, right? Right, we did this already, right? We did this, but we don't have this. We don't have routing protocol. You know, you can do it statically, but that's a lot. You know, we're gonna configure one static and we're gonna configure one default route. Okay. We'll figure this out. Okay. One default route will go to the ISP, and one static route will go back to R1. Okay. We're gonna be configuring that later on. But the next step that we're gonna be doing is we're gonna configure OSPF, which is what we're gonna be doing. Let's go and start off with R1. Okay. There we go. We're in R1 now. And let's do a config T. We have to go into global configuration mode. And the first step, I believe the first step, I'm trying to do this by memory, is we're going to do router OSPF. Okay. We'll give it a number of 10. Right. Router OSPF 10. Okay. Give it a router OSPF 10. And if we do a question mark, here's what we will see. We'll see exit, distance, default information. This is important. Default information, network, and neighbor. This is pretty good. No passive interfaces as well. Redistributes. And router ID. Okay, let's start off with the router ID. Router ID for this OSPF process. So the router ID is pretty good. It will, there are things called the main router. I believe that's what it's called. There's two neighbors, right? There's the BDR, I think, and the BR, which is like there's two bridge routers, and then there's one that's gonna be the secondary bridge router, and then there's gonna be one that is the main router that we're gonna be doing, and we want this to be the main router. So we're gonna do it. We're gonna give it a 1.1.1.1, right? So if we do a question mark, we can do it in IP format 1.1.1.1. And we'll also give it its network. I don't know what neighbor does. Let's see what neighbor does. Neighbor address? Whoa. But we're gonna be doing the one that I was taught was with the network address. So we're gonna be doing the network address for each one. So if we do a do show IP interface brief, the ones that we should be having here is actually our serial ports plus this gigabit Ethernet 0/1. So we'll do this. These on the network addresses. The reason why we're gonna be doing it on the network addresses right here for these is because we want these to communicate. I believe we want these to communicate. Actually, only the serial ports will be doing this because we want these ports to communicate and give off the OSPF packets to each other. Neighbor adjacency packets, from what it's called, I believe so. So here we go. What we're gonna do is that we're gonna do the neighbor command, right? Neighbor command, or not neighbor, sorry, network. So we're gonna give it the network address. So what is the network address of these two, right? So 192.168.1.192, and then what is this? Oh, OSPF wildcard bits. How do we do wildcard bits, right? Wildcard bits is basically you take the subnet of it and you just minus it by 255. So what is 255 minus 255? That's 0. What is 255 minus 255? 0.0. What is 255? What is 255 minus 252? Right? Oh, sorry. 255 minus 252. 3. So our wildcard is going to be 0.0.0.3. So now we're just going to add 0.0.0.3. What's next? Area. And we're going to give it an area of 0. Because you always want to make it as 0 first. 0 is the backbone, and this is what we're going to be doing for our lab purposes. 0 will be the backbone. Anything that is not 0 should be connected to any of these routers that are in the area 0 network. So there you go. That is our first network address. We'll just press up to reset it, and we'll just put in our other serial over here, which is .200. The .200 network. There you go. In fact, if you put in your interface, it will actually automatically know. It will automatically put in the network instead of your interface. So that's all you need to know. So here we go. We got R1 going, which is great. And one more command while we're in R1 is that we're gonna be doing a passive interface. Okay. What passive interface does is that we are passive interface stops the neighbor adjacency packets from reaching those interfaces, which, you know, we don't want the ISP to be getting these neighbor adjacency. We don't want our host to be also getting it too. We just want our routers, because these are the ones that are going to be connecting to each other. So we'll just give it right, we'll just give it the interfaces G0. Oops, we just want G00, and we'll also do it to G01. So now that these two are in passive interfaces, we'll also do a default information, because guess what? The reason why we do default information, we only need one default information, because we want all the routers to send the packets to one router that will send it to somewhere else, which will be the ISP. Okay, so let's go do a default originate, right? Default information, question mark, originate, and then question mark, and that's it. That is it for R1. And then while we're at it, we're also going to be making a default route. So let's exit out. Let's exit out of this, and we're going to be doing an IP route, right? An IP route command to route to the ISP using default originate. So we'll be doing a default route, which is all zeros for subnet and IP address, and we'll just shoot it out of the here, the G01 interface. Okay, let's see what we can do. Right, we want to do the forwarding router's address, or you want to make it out of the interface, you know? Let's just actually, you know what, just to make it a nice, like, specified one, we'll just give it its one. So let's go give it to 206. There you go. And then if we do a show IP route, which is the show commands that we're going to be doing, we have our default route. See, the gateway of last resort is 192.168.0.1 to network 0000. Great. All right. Notice how we have all these addresses as well, and we still do not have the OSPF. Right, OSPF is going to be right here with an O indicator. This is a S. Okay, so let's go to R2 now, and we'll go and configure OSPF on this one. Oh, looks like we logged out, but don't worry, we didn't put any password on this. So here we go. Let's go do router OSPF 10. Right, we want to have them basically in the same function of OSPF. We want router OSPF 10. We want to add in a router ID of 2.2.2.2, you know, just to keep it uniform with R2. And we're going to be doing a network, right? We're going to be doing a network of 192.168.1.192 with the wildcard bits being .3, area 0. Same thing. We're just going to be doing the same thing. A lot of repetitions. And we're going to be doing a passive interface as well to G00. And there you go. All right. Now, look at this. The router, right? Router 1 and router 2 should have an update. Notice how they created a adjacency. See? Look at this. It's cool, right? Look at that. From process 10, from router OSPF 10, R2 can see R1, which is the neighbor of 1.1.1.1, and this is the neighbor from R1 to 1.2.2.2.2 through this interface, loading to full, loading, done. That means they see each other. Cool, right? This is networking at its finest. Pretty cool. Alright, let's go and since we did this already, we did the basic things that we already needed. We did the neighbor, or we did the network command and the passive interface. Okay, we don't really need to do redistribute. That's too much out of our hands right now, and we'll be doing a router ID. Alright, we can also change the auto cost, right? Auto cost can also change some factors. With the auto cost can also change the bandwidth factors of these router IDs and how they are, you know, electing their neighbor adjacencies. But you know, it's good for now. Which the router IDs definitely they overtake the costs, which what we're trying to do here. So here we go. Let's go to R3 now. Right, let's go to R3. Let's go extend this. Enable configure terminal, and let's go do router OSPF 10. Let's go do this router ID 3.3.3.3. Great. And let's go do a network command, which is 192.168.1.200. 0.0.0.3 for the wildcard area 0, because this is the backbone. It's only one network we're going to be configuring, and we're going to be skipping this as well. Let's go and change this to 196, and there you go. Notice how it already says that, hey man, we see each other. The routers are basically saying they're sending their own little packets to each other, saying, hey, I see you. Hi neighbor. Hello. Hi R2. Hi R1. This is basically what R3 is saying. And R1 and R2 are basically saying, hey, how are you doing? You know? But we do not want PC3 to be getting these packets. You know, if we do simulation mode, we'll see that it's sending packets, but you know, PC3 is, you know, not gonna take it, of course, which is gonna be a waste of bandwidth. So that's why we do these passive interfaces. You know, also for security's sake. So passive interface G00. Okay. Here we go. This is great. Right? This is great. So let's go and try pinging now. We should be able to ping between us right here. And maybe we should be able to ping .206, but not really. Maybe we can be able to ping to 210 and it will receive it, but it cannot receive back because on the ISP it doesn't have a way to get here. This is why we're gonna make a static route going to R1. Okay, but first we're gonna be testing out the ping system from PC2 to PC3 and we're gonna do PC2 to PC3 and PC2 to PC1, and this should work actually. 192.168.1.62. Let's see. Oh, request timeout. Oh no, this is not looking so good. Okay, let's try this. .190. If we could figure out what's wrong, then, you know, that's great. Alright, looks like we are... Oh, wait a minute. I think I figured out what's wrong. I think we have to also put the neighbor as our addresses here too. Let's go and try this out, okay? Configure. Let's go do router OSPF 10. Back to our thing, and let's go and also add the network here. Let's go and add the regular networks, which is 192.168.1.0, 0.0.0. Oops, we need to go and figure this out, right? What is 192 minus 255, right? So let's go to this. 255 minus 192.63. Okay, let's go add a .63 right here. .63, right? .63, area 0, and there you go. Let's go also do this for not PC2, but R2 as well. Are we here already? Let's go do this. Router OSPF 10. And let's go add a network. Network of 192.168.1.64, 0.0.0.63, area 0. And let's do R3 as well. Router OSPF 10. See if we have this one. Okay, that's great. We already have this going, so we can just do this faster. 128 and .63. Great. Now I feel like we should be able to ping now from PC2. So let's go and see. Yep, there you go. Now we're able to ping. Great. Wow. Congratulations, everyone. We did our first ever router OSPF, right? Looks like we were able to do it for both, right? TTL 126. But can we ping the ISP, right? We already put a default route there. We should be able to, right? Oh, what's going on? We are not able to ping the ISP. Well, here's the thing, right? We're pinging to the ISP, but the ISP doesn't have a way to ping back. So anything from the ISP over here is not connected to the network, right? We already have a default originate, which will take all the packets and shoot it out one area. So let's go and configure a static route going back to R1. So let's go and do it right here, right? Enable, configure terminal, and let's do an IP route. We'll do a static route, actually. We're gonna do an IP route, destination prefix, IP route 192.168.202. Oops, .1.202. Destination prefix mask 255.255.255.252, and forwarding router address, which is 192.168.1.206. Oops, we did something going on here. Inconsistent address and mask. Oops, it's not 202. Sorry. Sorry, everyone. It's not 202. It's actually 205. I'm joking. All right. Whoopsies. Even worse. 206. 205. What's going on? Wait, hold on. I believe we did something wrong here then. Right? Exit. Let's do a do show IP IP route. Right? Notice how we have the OSPF OSPF neighbor adjacencies already, but my interest is here. Right? Via 206. But 206 needs to find a way back, which we're going to be doing an IP route going back. 192.168. dot 1 dot 205 255 dot 0. I think we should do it dot 0 because everyone needs to get the whole address, right? Because dot 0 is everything. And then let's see, 192.168 dot 1.206 because that's the forwarding address going out. Inconsistent mask. What if we just put its D00 interface? You know what? Default route without gateway, if not a point-to-point interface, may impact performance. We'll see. We'll see now. Do show IP route. See an IP route now. We're trying to make a static route. There's something going on here that we do not know. What is this? Destination prefix. Which is the 192.168, right? And 192.168.1.205, right? Two five five 255.255.0. It's inconsistent. What if we just change it to another one, like 202? No, not 202. What about 193? Or dot 1? Wait, hold on, guys. This is crazy. So we got a default static route. Okay, wait. Hold on, I need to go and figure this out. Wait a minute. Oh. What about this? IP route 192.168.1.206. Like any information coming from 206. Dot 0, like any information coming from this, from all addresses, will be shooting out to 192.168.1.205. Inconsistent mask and address. What's going on? Oh. We are stumbling right now, or I am stumbling. IP route. Holy cow! I'm not gonna cut this out because I'm you know, trial and error is the way to go. Actually, IP route 192.168.1. Oh my gosh, I'm an idiot. Guys, okay, I'm an idiot. Okay, everyone, guess what? I forgot. I remember when I was learning my CCNA, the IP static route, right? I'm learning it right now, but like, you know, it's been a while. I'm already on like spanning tree when relearning actually. It's actually your network address. And then we're gonna put this as 255.0. The reason why we do 255.0 is because we want everything. The /30 and the /24, and the /26 is covered by the /24 subnet mask. And then we'll shoot this one out of .206's interface. And this should be correct. What? No way. Is it 252? There's no way. Right? Oh, invalid next hop. This is the router. The 205? Oh, okay. Well, you know what? Let's see. Okay. Let's do a show IP route. Show IP route static. Do show run. Let's see if we're able to ping. Ping 192.168.1.206. Okay, looks like we're not able to yet. Okay, so let's do a yeah, we'll see this. We'll try to oh, wait a minute, maybe I did something wrong, right? Let's go and do a no here, right? Let's do a no matching route to delete. Oh, it just never created it. What if we just shove it into .202? Oh, whoopsies. What if we just shove it into .202, like into the network? Will that work? I believe that will work then, I guess. Seems like it would work. .0. We're on a stump here, guys. Okay, hold on. So IP route destination prefix. Um 1.200 5.255.0 68.1.205 inconsistent maps 252. Will that work? No. Hold on. Okay, we have all these useless stuff that I created. Man. Let's do a no. I know if we're not supposed to be doing the I know we're not supposed to be doing the stuff. Show. Hold on, everyone. This is getting to me. This is like one of the basic things that I can't do it. That's why I'm really like, wow. IP route, destination prefix. Where should the destination prefix be then? Right? Should it be in the 192.168.1 dot? 1.0? 255, 255, 255.0? This only makes sense. This only makes sense because the 1.0 is everything, and then 255.0, and then we'll just shoot it out of the port right here. You think that'll work? It makes sense, right? Like 1.0 is like from 1.0 going around. 255.0, that means everyone's gonna be in it. So every address in that zone should be able to get pinged. Oh, there you go. Hey, let's go. All right. See, now that right there, it's embarrassing that it took a long time, but you know, you guys got to see like me being an idiot at its finest, and also me fixing it, which is an easy fix as its finest, right? So, right now, let's go document this, right? So, what do you want to document about it, right? So, wait, hold on. Before we do anything, let's go see if we're able to ping the server. 210, and we're able to ping the server. Great job, everyone. That's good. So now we're able to ping the server from every PC. Let's go test it out. Go ping .1.210, and we should be able to, which is great. So let's go and let's go right here to the ISP and figure out why this worked, right? So let's go do a exit, do show IP route, right? So do a show IP route first before we do the rest. So let's go, here we go. We got a static going on here. Notice how we got a static going from this through this network, going through this network to 205, which will distribute everywhere. But we also have a 192.0.1 going out the thing as well. It makes two because it's one's like tunneling through as well. So the reason why we have this is because .10/24 it will include all the addresses in our network. Like, notice how /26 is only this much. If we do a /24, it includes everyone, and that's why that was important. So, you know, kudos. That was great. You know, I haven't done this in a while, so this is great. This is great to understand and know that that's how it worked. So, you know, the next command that we're going to be doing, let's go to R1, is that we're going to be checking out the neighbor adjacencies. You know, now that we have everything working, okay, password and password. Okay, now that we have everything working, we'll be doing the show commands. Right, so we got this. Oh, actually, we should be saving our configuration. So there's three ways you can save your configuration. We have the right, okay, right, erase, whatever. We have the right. Let's just do this, right? We have right. There you go. See, it built it. And if we do the show startup config, I believe it should have everything we have. See, even the IP route and everything, our banner MOTD as well. We also have copy running config startup config. Yep. And we also have another one, but I forgot. But you know, the shortcut of it is right as well. You can also do it right. So let's go do it right for everyone. But you know, for the CCNA, um, I definitely you should do copy running startup config, because that's basically, I think that's what they're gonna teach you mainly. I'm learning the CCNA, so you know, trust me on that one. I'm still trying to grind for that CCNA, but you know, you learn some shortcuts along the way. So now we have everything saved up. Let's go and tag this out. Right, we saved our configuration. We did router OSPF, and now we're gonna be doing the show commands. Okay, so the show commands are mainly important over here. So let's go do the show IP route. We did this a couple times to troubleshoot. Notice how we have O's now, right? We have O's, meaning for OSPF. Look at this, 192.0.1 via 192.1.93. Notice how everything, like, they understand each other. See, that 193, right? We also have the 128 via 198. See, like, look at this. Like, when you're doing the OSPF, you just understand everything. Like, everyone will understand each other on the neighbor adjacency. They're basically sending each other a routing table of some sort to each other, which eventually they all like combine together. I believe I forgot. They all combine together. I don't know what's the word. They converge together, and that's how this is like a really good routing protocol, because you know, it's I guess it's somewhat like more automated. Like they understand each other. And then if you just wanted to add one more, if you wanted to add one more router, you just add the neighbors across, and then it would understand what R3 is, you know. And then notice how we have a OE2. Okay, so OE2, what that means is that this is a default originate, and its default originate, it's gonna shoot. It's basically, what this means is that let's see, right? See, there we go. E2, OSPF external type 2. So the external type 2, that means that what's going to happen is that we want to shoot out information out of this OSPF area into an area that it doesn't really know, which is the ISP. So we have to do a default route to get all of the IP packets to be gathered regardless, right? This, which is 0000, and we're going to shoot it out of here. The default originate allows all the packets to go to R1, and that's it, right? And then the ISP, definitely, you know, you're gonna have to get the ISP, shoot out a static. You do not want everything from the ISP going to a single network. That's like security hazard. So you know, you just want a random, like a static route going back, so you know you're able to have a full connectivity, pinging here, and then a static route to ping back to R1, which is great, right? We'll also do another command, which is show IP OSPF. Okay, now this one has a lot more into this. We got the routing process of OSPF 10 with the router ID of 2222, right? Notice how everything is all good, right? See, notice how it even has it knows it. So let's go to R1 actually, because it I forgot to show you this. Show IP. There we go. So look, now this one has the static route, but this one has the O, because you know, R1 is the default originate and R3 isn't, or R2 and R3 isn't. So, but you know how OSPF works is that they already understand that they need to send it to R1 because he's the main router. Okay, so let's go see this. See, now let's go see this. So look at this. We have OSPF 10 with the router ID of 2.2.2.2, right? We got we got stub areas, normal areas. You'll learn that later on. NSSA. We got the area backbone of 0. See? Let's see this. LSA 3. Lots of things. Floodless length. We got lots of troubleshooting things you can do here. Okay. And then let's go to R2. Oh, we already did it in R2. Great. See? Okay, now this is one command that I believe that let's do this again here. Show IP OSPF. See? Same thing. But this time you'll know it's the router process and the ID. That's the main thing you'll get from here. And you'll see the LSAs being sent around. One command that's really important that you should know is the show IP OSPF neighbor. This one's really important. It will show you the neighbors. It's pretty nice. You get to see how the priority works, right? There's priority, dead time, there's the address. So these are the neighbors that it knows. Show IP OSPF neighbor command. Pretty good, see? Full state. And then we can also do show IP OSPF interface as well, which will show us a lot more, which is nice. See? It's nice to have it. Nice to have it. Definitely nice to have it. So let's go and see, right? Let's go see what we're going here. We got the point-to-point networks. Oh, wait a minute. Got the network type broadcast. We got the point-to-point type networks, which is nice. I believe what we really wanted is the broadcast, I think. But, you know, maybe that'll be in another video. I'll show you guys in another video after. I'll save this definitely. See, notice we got the G00, we got the no hellos passive interfaces. We got the hello 10, dead 40, wait 40. The retransmit of 5. It's cool. Look at that, router ID 10. And this. It's pretty nice. Point to point. Well, there you go. I believe that there's a way to change it to broadcast, and maybe if you maybe we can try it out right now. Actually, I think it's gonna be in configure terminal mode, and we'll see if we can. We'll see if we can change it. Okay, let's see router OSPF, and we'll just check this one out. Area, auto cost, distance. Neighbor. Log adjacency changes. Oh, that's good. See if we got any way to change it. Interface, IP. Priority list. If we do router, see what we can do here. Priority list. Well, we'll do more later on, but we'll be figuring this out later on. If anything, I'm just gonna pause the recording now, and then when I research, I'll tell you guys. Here we go. So after doing some research, it looks like we're gonna have to go to the interface and do an IP OSPF network broadcast. It's good to refresh my memory. That's really nice. So let's go start it off with R1, right? See, look, now this is what I was missing. See, this is where it's supposed to be like designated route and like something like that. It's supposed to be like that. Like there's supposed to be a main, and then there's a another like that. Let's see this, right? NBR, see like neighbor, right? DR other direct something, right? Like you would want it to be like that. You want to have like the DR, unless it's a point to point, which is, you know, the one that we have right now is point to point, which is, you know, it's fine because it's point to point. But you know, if you want it to elect stuff, which is what you really want, then you want it to be in like the DR, BDR, and the DR, BDR, you know, and the others, right? Let's go and do that right now. So let's go do interface. AS0 interface range, right? Okay, wait, actually, let's do conti interface range S001 and S0/1/1. Okay. Interface range. Okay, it doesn't do serial ports. Okay. We'll just do that then, I guess. Yeah, S0/1/0. There you go, sorry. S0/1/0. I guess the range doesn't give it then. And then we'll just follow the network? Oh, no, sorry. IP, OSPF, network. There you go. Wait, network. Broadcast. There you go. And then let's go have a little look actually. There you go. Specifies OSPF broadcast multi-access network and a point-to-point. You know, point-to-point is great, but I think the interesting part is actually the broadcast, which is really nice. So let's go do these. Right, we'll give it a broadcast, and then we'll go to 011, and we'll also give it a IP OSPF broadcast. And then let's go to R2 as well. Conti interface S0/1/0 IP OSPF network broadcast. And then we'll do this as well. These should all change. I believe so. 0 IP OSPF network broadcast. Just change this to a 1. Okay. I don't know what happened, but we'll go back to exit, right? We'll exit again, and we'll do the show command. There you go. Our network type is broadcast. No designated router on this network. No backup designated router on this network. I guess we're gonna have to wait for it to do its thing. I believe that the designated router and the backup designated router takes a while to elect, so we'll just like kind of just scroll through time, and let's see what we can do here. Show IP OSPF interface. Okay. Oh, wait a minute. Oh, this is the DR, yeah. Designated router. So it looks like R3 is none of those. Let's check out R2 if it's any of like the designated router or not. Show IP OSPF interface. No designated router. Maybe it's because I added a router ID that it doesn't really need it. Password. Enable password. Show IP OSPF. Show IP OSPF interface. least we have broadcast going. Show IP OSPF neighbor. There you go. Okay, so we have DR others. Ah, cool. We got, at least it's showing something. We'll figure this out in the future. Show IP OSPF neighbor. It looks like everything is DR other. Maybe it's because of the... Maybe it doesn't need... Like if I take this out, maybe if I take out the neighbor ID. Maybe that's the reason why. Well,